Good morning. It's always great to have a keynote on a second day after the party. But I'm not the first one. I see you actually recover quite well. I mean, that's your reputation as Finn. So, my name is Schwegler. I'm Swiss, which might explain my lack of humor, but I think that's something we share in common. So for today, I'm going to have 60 minutes to introduce you into Windows Azure. I'm going to show you 4 demos, so we're going to spend half of the time actually doing some demos. I want to introduce you to some big data demo. I want to show you more on mobile services, and I want to show you some HPC, high-performance computing solutions which have been built on Windows Azure. So let's just start. I mean, what's happening? Oops. Wrong button. So what's happening in the industry? There is a big disruption taking place. And there are four mega trends where basically the 3 of them are supported by the cloud. So mobility. We have devices. We're connected every time and everywhere. We can share data because of the cloud capabilities. Social. The ability to like, follow, share, and friend. But in a B2B scenario, it's also the ability to reflect social graphs across companies because we have federated identity provided by the cloud. And then big data. I mean, for the first time, we can store data at the very, very low price point. But it's not only about storing data. It's also about retrieving information out of these huge data sets, which is possible with big data technologies like Hadoop, which is based on a distributed file system and has actually a framework on top, which is called MapReduce, which allows us to run extremely parallel compute tasks on top of huge data sets. And I'm going to introduce you to this later on. So for me, it was very obvious that, I mean, the cloud is the enabler for these trends. It's not a cloud solution that you're going to build by its own. It's always something different that you're going to enable through cloud capabilities. And that's why I'm so excited about being quite focused on cloud computing for the last couple of years. You might have seen this many, many times, but I took the time to actually create a nicely boxed version. So if you look at the continuous of the IT spectrum, where on one side you have the private cloud, where you physically own the servers, or you start to virtualize your servers. And on the other side, you consume your services from the cloud directly, either as software as a service, or platform as a service, or infrastructure as a service. So if you look at this, what is the huge difference between owning a data center, running your data center and infrastructure as a service versus platform and software as a service? Only platform and software as a service requires you not, with the focus on not to manage that stuff yourself. You get it as a service. If you look at the, currently, I mean, there is a steep trend in adopting infrastructure as a service, which literally is nothing else than having virtualization in a cloud, which still requires you to manage that system, which means patch your operating systems, configure your load balancers, and so forth. So that's kind of one of the key differentiations there. Only platform as a service and software as a service allow you to to focus on the business at hand rather than the underlying infrastructure. The other category you could apply is how do you pay for it? And then it's fairly obvious, if you own the data center, you pay for it, you own it. So it's infrastructure, platform, and software as a service, which has a pay-as-you-go model. That's kind of the whole ecosystem at the moment. So if you look at this, why aren't we doing just private cloud? Or what is the benefit of public cloud? Private cloud is about control. And public cloud is about the economy of scale. If you look here, it's fairly obvious that the cost of servers per server comes down the more servers you have. If you actually operate a data center of 10,000 of servers, you have a total cost of ownership which is below 10% than if you would just operate 100 servers. And that is what allows us to suddenly, come up with great business opportunities, which suddenly going to be financially viable. Because now we can get 50 servers to a similar cost than actually the largest organizations have their cost designed for. So we offer you that economy of scale. We offer you to benefit from that one. And that is why the public cloud has a complete different economy than the private cloud. So how is this possible? Who visited a large-scale data center? So really a data warehouse-sized data center. I mean, this is if you get the chance, really do it. It's an amazing experience. So for instance, Ireland, just to give you an example, the whole Dublin data center, Microsoft's Dublin data center is in a no-fly zone. Ireland is not known for having a lot of tanks, but there is actually a tank barrier in front of the data center that the few tanks can't enter the data center. What you see here is one of the UPS aggregates. Everything is co-located. So for one set, we actually have two of them. They're designed to switch on within a fraction of a second. But if this is not the case, we actually have a battery room which can run the whole data center for 20 minutes. Just imagine, you have a battery room to run a data center for 20 minutes. So everything is co-located there. And you start to realize, wow, running a data center is actually not so much about IT. It is a lot about engineering, electrical engineering. It has a lot to do about energy. It has a lot to do how do you actually do cooling and all that stuff. Just to give you an example, the Dublin data center is actually cooled by natural airflow. So we have water that dribbles down, and because in Ireland it's never really warm, you don't really need to cool it actively. So that is the type of sophistication that goes into this. And what you see up there, this is kind of the operation center. This is not in Dublin or in Amsterdam or in any other data centers that we have. No, that's something you can do from remote. And if something fails, it fails because the data center is designed to handle failure without an issue. So now let me kind of introduce you to our cloud platform offering, Windows Azure. So we have other, as you know, Microsoft has, for instance, Office 365, we have Xbox Live, and other cloud services like Bing and Hotmail. They're all running out of these data centers. So does Windows Azure, which is our cloud platform for developers. So first of all, by using Windows Azure, you get access to 8 data centers, 4 in the US, 2 in Europe, and 2 in Asia. In addition to this, you also get access to our content delivery network and its edge nodes. So these are the green spots that you actually see. So that means, we actually cache stuff at the edge of our network. So you get access to 24 of them. We provide you a 99.95 SLA, which is an equivalent of a downtime of 20 minutes per month. That includes patching and all that stuff. That's the downtime. And you pay only for what you use. There is no upfront payment. You can start today. If your business is not working well, you're not really going to pay for it. So if you look at Windows Azure, the one thing which is fundamentally different, and you saw this already from Tim yesterday in his keynote, it is a really open platform. It's not just Windows, and it's not just .NET. We support Linux. We are a first-class platform for PHP, Node.js, Java, Python. It's extremely flexible. We don't put you into a specific application format. You can actually pick the one which suits you best. And if you look at the capabilities that we provide, so there are 6 boxes that I would like to discuss quickly. Cloud services. This is a way how you can package your software, your application, configure it, and then we run it for you. We actually, configure the load balancers and all that stuff. It's for highly scalable application. I'm going to show to you an HPC example later on that one. Websites is if you want to have your WordPress, your Node.js, your PHP site running in a more shared mode, because this is economically very interesting, this is what websites are good for. Virtual machines. This is our infrastructure as a service offering for Windows Server and for Linux. This is where you actually need to manage the OS yourself. You need to manage the network configuration yourself too. Mobile services, Yuka already introduced you yesterday to this. I'm going to go a little bit more into detail, how you can do authentication, how you can do push notification, and how you can run back-end schedulers on top of that. And then we also have a Windows Store, which allows you either to consume services, so like MySQL services delivered by ClearDB as a service, so you don't have to install it, you just, get the connection string and run your stuff. I for instance, run my weblog as a WordPress site out of this. So all my stuff is stored in ClearDB. So it could be your offering. If you have a service, you can actually sell it to other developers through the store. And on the very top, you see also building blocks. This is stuff like a traffic manager that routes traffic depending on latency, depending on availability or location. This comes along with media services, which allow you to encode videos, to stream videos, to publish videos. There are many other building blocks available there. But instead of just talking a lot of this stuff, I'm just going to show it to you. But before I do this, I just want to give you an idea of what is all the different stuff which is actually available on Windows Azure. And more importantly, we actively contribute to these communities. It's not like we take a fork and kind of bury it within Microsoft and keep it to ourselves. No, our goal is that PHP runs best on Windows Azure. We actively contribute to this. And the same applies to every other technology as well. But let's have a look. So if you can switch to my demo machine. Oops. Oops, that's a policy. They put my computer. Okay, it's not locked. That was good. It was the 3rd try, so that would be an interesting keynote. So what you see here is the portal, windowsazure.com. So you just go to windowsazure.com. I quickly want to navigate you through this because, as you can imagine, a service is delivered quite frequently and changes are delivered quite frequently. So knowing where to find stuff is actually very, very good. So first of all, if you want to know what are the different features, you want to learn about this, all the stuff I already was talking about, you go in the Features tab, you see an explanation about websites are, the different capabilities, virtual machines. So for instance, mobile services, you can read more about all the stuff that Yuka was talking about. If you want to get more details, so for instance, later on I'm going to show you push notification, I'm going to show you the script model of mobile services. you can actually go on documentation, and then you have a reference tag here. You see that on the left side? And you have a full documentation of the full script model. So if you want to send, for instance, push notification, this is a description of all the different push notification methods you can use for Windows 8 and Windows Phone, for instance. Another way is to calculate or estimate your prices. So you, for instance, see that 10 websites are free. If you want to have, for instance, storage. So let's say you want to store some data. You simply can just use the calculator and see, okay, it's something like 11 terabyte of data costs me something like $700. So you kind of get an idea that storing stuff is actually becoming really, really expensive compared to how it was previously. Because this is active data. You can run query on that stuff. It's not on a tape somewhere. But now let's kind of show you also the SDK, because I think that's something I think is really cool. So on one side, for mobile services, we provide you an iOS SDK, soon an Android SDK. If you look Node.js, we provide you with Windows, Mac, Linux SDKs, the same for PHP, Java, Python. We don't impose where you develop. We're just going to guarantee you that if you run it on Windows Azure, we're going to ensure it is a first-class citizen there. So now let's go on a portal. So the portal is where I manage my stuff. I want to show you two things first on this demo. And this is around websites. On the left side, obviously, you see the different service capabilities that I have. At the very top one are the websites. I already have a couple of them. So what I'm going to do is, my blog runs out of WordPress here, which is actually a website. I brought in my domain, which is CloudPH. So what we're going to do is we create a simple WordPress website, and then I'm going to link it to my existing MySQL server, which runs under ClearDB. So which means we should actually have my website surfaced in another front-end instance, if it works. So we'll see. So let's create a new website. And this time, because I want to have WordPress, I actually want to create it from a gallery. And we work with many providers to actually have their applications present in this gallery. So you see Composite, for instance, which is a Danish company. You also see, for instance, Joomla. We have Drupal, Umbraco. And on the very bottom, I have my WordPress, which means I don't have to install that stuff. It is a platform as a service. We just do this for you, and you just configure it later on. We also patch it for you. So I'm going to take this WordPress site, and I'm going to call this Hell for Helsinki. You see this green kind of check mark that says no one else picked that name so far, which makes me very lucky. I pick my subscription. I have multiple subscriptions, and because my subscription is actually for my blog is here, and I pick the location where I want to deploy my service. So I'm going to say I want to deploy it to Western Europe, but that's because this is also where my service is deployed, my database is deployed. So with this, I now just pick my database, which is my blog database. I agree to the terms of condition of ClearDB, which is delivered as part of the Windows Azure store, and I accept this. And now it creates my WordPress site and links it up directly with my MySQL server, which runs under ClearDB. That shouldn't take longer than a couple of seconds. And we should actually have a second instance of my blog deployed. So what you see here is also, it always tells you what task currently takes place. So now my service is up and running. Did someone look on it? It was in a minute. So I go on my dashboard because that's where I have my link. So this is my URL. You see my prefix and then azurewebsites.net. And this is my blog. Deployed within how many seconds? This is cool, isn't it? That you can do with Joomla, Drupal, whatever. Because we do the stuff which, takes a little bit more time. If you would, for instance, you can configure it. So you can change PHP versions. You can change .NET versions. You can actually change connection strings. Without, stopping stuff, without RDP into that service. I think this is really, really cool. If you want to have more instances, you can scale it. Because you just wrote a very controversial blog post. You're going to say, okay, now I'm going to have 3 instances. And if you go on shared, so there are 3 models. It's free, shared, and reserved. With reserved, you have a whole VM for yourself. With shared, it allows you to bring your own domain name. That's what I did. That's why my blog has its own domain name, but it rounds off nothing else than websites. So let's do something different. So that was good. So what I want to do next is, who uses GitHub? Okay. So for the ones who don't know GitHub, GitHub is kind of a code repository for social coding. It's used by many, many open source projects. And all our stuff is also published to GitHub. Our training kits, our SDKs, it all goes to GitHub, which means you can fork off, you can contribute, and you can actually automatically deploy that stuff to websites, which I think is really, really cool. Which means I have a repository on GitHub. This is my GitHub. I already logged in. You see I have 4 repositories here. And I created one for Tax Day Helsinki, which is a very, very simple website. So you see under content, I have a PDF file, which is the PDF of my presentation. And I have a title image, which is... I'm not going to show you that. Which is just the title that we're going to see there. And then I have my default. You see I put a title. And then I have an href with the content. Now that's all. So what I want to do is now, I want to tell Windows Azure, create an empty website, and tell Windows Azure that it should actually suck down that repository. And every time I commit something to this repository, it should be out there, updated automatically on my website. And this is actually extremely simple to do. So I just create a new website. This time I do a quick create, which means I do not have any of the gallery applications there. And let's call this Helsinki Keynote. Oh, that's taken. Helsinki, Helk. So it's Helk at azurewebsites.net. So that's where you can download the PDF of the presentation, hopefully in a couple of seconds. So I just create this one. So let's see. On my dashboard, you see this site is already created. So what I have now, I have the possibility to set up deployments with TFS or Git. There is actually more. I can deploy directly from Coplex. You can actually use also Web Matrix to directly deploy. So I'm going to use my GitHub option. And now it retrieves information from GitHub. So these are my repositories. So it's Tech Days Helsinki. I'm going to use the master branch, because that's the only one I have at the moment there. What's happening now is it establishes this connection, and it synchronizes the repository down to Windows Azure. So you already see my web application, which is on GitHub, starts to deploy in Windows Azure. And most likely in a couple of seconds, it is already up and running. So you can actually hit that URL here. And you see this is my presentation. You can download the PDF file. If I would now commit a new version to it, to GitHub, it would automatically go to Windows Azure websites too. This is pretty cool, isn't it? I mean, this is just a PDF file and an image, but it could be your application. It could be your test environment or whatever. So let's kind of switch gears. And can you switch back to my slides? Yeah, thank you. So the next topic I would like to talk about are cloud services. So we saw websites. Now, cloud services is our platform as a service capability to write near to infinitely scalable systems. It's based on an n-tier architecture where you're going to have your front-end nodes, which we call web roles, which run in the context of IIS. And then you have worker roles, which really do the back-end work. And you would communicate between them most likely through queues to really allow asynchronous communication and to scale these two tiers independently. And then you're going to have a couple of storage options, which I'm going to cover in more detail later on. The great thing is, you actually deliver this package together with a configuration file, which tells Windows Azure how it has to configure the load balancers and so forth. And you then just say, OK, I want to have more of the backend processing service. I'm going to from 5 instances to 10 instances, and we just do this like magic. So let's have a look at the workflow, how this actually works. So you have your service package, which means you develop your piece of software either with Visual Studio or with the command line tools. And then you're going to deploy this. So it's like a package that contains your DLLs, your binary files, but also the configuration manifest that tells Windows Azure how to configure that service. So you deploy this to the Windows Azure. What Windows Azure now does, it realizes how many instances of virtual machines it has to spun up. In this case, 4. And once they're ready, we're going to deploy our package down there and start up that particular service. After this, we're actually going to configure the network load balancers, and your solution is ready to go. Now, if we realize that one of our servers is actually going down, we just take it out, spun up a new one, and redeploy the package. If you have a very, very successful solution and you're going to get 50% more demand, you want to have 2 more instances, what are we going to do? We just add 2 more instances and deploy the package. That's all it takes. Obviously, the solution, the n-tier solution, as I was saying, communicates most likely to queues. You don't want to keep state between calls. So that requires you to think good about where do you actually store state. And within cloud services or any other Windows Azure solution, you basically have 4 options. You can store it in a non-SQL storage, which we call table storage, which is very, very cheap, which is also very, very scalable. It's literally infinite scalable. But it requires you to think about how you partition data. Then we have blobs. That's where we store binary files. That's actually also where we store the virtual images if you use virtual machines. Queues, predominantly for communication between systems. And then SQL database, it's really a relational database, but it comes with size constraints. It is managed as a service within Windows Azure, so you don't have to do this. But if you need to store a terabyte of data, you're most likely going towards tables and blobs and use the SQL database as a service only for your most frequent transactional data. So what does now this give to you? You have access to near to unlimited compute power. You have access to near to unlimited storage. That radically changes the way who can develop what and how many people you can reach, because we have a global set of data centers. So it really democratizes access to scale, so who can actually write large-scale solutions, and it democratizes how many people you can reach. Because you're suddenly going to get access to 24 H nodes which are distributed across the globe. So you can actually provide a streaming solution worldwide. And if you want to do high-performance computing, you get access to 100 nodes without investing up front, which wasn't really possible before this. So what I want to show you is something that really demonstrates this, and it's a weather forecast. So we actually did on Windows Azure, with cloud services, a weather forecast. And it was a little team that developed it. Just to put this into perspective, Craig supercomputers actually have been developed to do weather forecasts. And now you as a small team can run this stuff for yourself. It is based on a weather research and forecasting model, and we use publicly available data. Basically data from the National Center for Atmospheric Research. So let me show you how that stuff actually works. So this is a public URL. So it's the weather service at cloudapp.net. Cloudapp is the URL, that the domain name that we use for cloud services if you don't bring your own. So with the gallery here, I just want to show you how many forecasts we already did. Going on a map just shows you the many different forecasts we did worldwide. And I did a couple for Helsinki. I was looking for some interesting weather. You know, if you travel to places like Dubai and you want to show them the weather there, it's kind of a boring weather forecast. So coming to Helsinki, I knew it's going to be good. And I'm not disappointed. So I have a weather forecast that I started on the 5th. Yeah, this one. So let's have a look at this. And we overlay that actually on top of Bing Map. So now we have hourly frames of snow, which starts fairly soon. So you see how the snow developed over Helsinki over time. You see the amount of snow. And all that stuff has been calculated using Windows Azure on a backend. If you want to do, for instance, your own forecast, you just say, I want to do a new forecast. I'm actually interested in the weather in, as we were saying, yeah, get kind of a feeling how it could be. Dubai. I just give a quick description, and that's the 06. There are people who just say home. I think that's a bit unfair. I just give other people the opportunity to have the pleasure with my weather forecast too. So that's why I named them accurately. So what you see now, the job has been created. So after this, it actually gets handed over to the HPC scheduler, and then it gets processed. So if you look at the processing queue here, I have another one that I created for Helsinki. The forecast is now at 55%. It's literally a queue our scheduler works on. If you can switch back to the slides, please. If you now look into the management portal, you see that we have the opportunity to provision up to 128 cores. It's a decent size of servers for a small team. But even more interesting is that we have a utilization of the 12 cores here at 98.38% because it's very predictable. It's an algorithm we run on top of a predictable set of data. If you look at the architecture, it's very simple. We have a head node, which is the job scheduler for the HPC. We have a front-end node. That was basically the website that I showed you. And then we have the compute nodes, which are the extra large instances because we're going to have a lot of compute. The other ones were actually run on smaller instances. It's fairly straightforward. And that's what I mean with the democratizing of scale and reach. Stuff becomes possible that hasn't been possible 10 years back, at least not without investing upfront quite heavily. Let me talk a little bit about data. So data becomes the new currency. It's an interesting statement, isn't it? So who of you stores all weblog information? All. So no one. So that means you throw information away. Most likely what you do, and that's just me making an assumption, you look at your weblog and you strip out stuff that you're interested in, and then you feed it into either a data warehousing or another BI technology. Is this correct? If you're not throwing the whole weblog away. But what this means, if you reflect on this, what this means is that you decide at the time when you store the data or throw the stuff away, what information is going to be useful for you in the future. And unfortunately, you do not know that. So with big data, you have the ability to store data across multiple nodes fairly cheap. And we have technology that allows you to make sense out of this data, maybe in an experimental way. So imagine you have a commerce website, and you have a lot of data, but you just kept it. And then suddenly, the Finnish TV company releases another data set which actually gives you insight into commercials they run. Because you haven't thrown that stuff away, you can now start to correlate these two data sets and maybe get some intelligence out how certain commercials impact the usage of your website. So data is really something that you either can consume, so actually getting data from others, like we got the weather data, or you expose, because you have a data set that is going to be interesting for others too. But before you can do this, you need to store, and store, and store, and store your data. Do not throw stuff away, except it's a useless binary dump, which is not from a crash. Because even crash data can become statistically relevant if you have enough of it. So then you store, and then you have so much that you have to move the compute to the data. So the two big data rules are store, 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 and because you stored so much, you have to compute where you stored the data. One of the most common technologies used for big data at the moment is actually Hadoop, which is based on Java. Who knows Hadoop? So let me quickly give you an introduction, and I'm going to show you a demo so you get a better understanding of it. So Hadoop, on its very foundation, so Hadoop is actually an open source project by Apache. And everything has to do with animals, as you see. So we have the pig and hive, and we have Scoop, and we have the zookeeper, and there is actually many more. But on the very foundation, it's a distributed file system. That means you can look at the peta or multiple petabyte of data as it would be stored in one location. So it abstracts this complexity of storing it across a couple of nodes and the partitioning from you. And then it comes with a, not an algorithm, but with a framework which is based on MapReduce. And I'm going to go into MapReduce a little bit in more detail. That allows you to run compute tasks on top of that data in a massive parallel way. So if you have your data spread across 10,000 servers, you can now do compute calculations on each of these servers, and you're going to get one result back. You also have, you actually have additional technology on top. So Pig allows you to say, I'm going to take this data, run that MapReduce algorithm, and I'm going to store this data now here. Hive allows you to have a SQL-like way to manipulate that data, and I'm going to show you how this connects to ODBC and visualize some very interesting data in Excel. And then Scoop allows you to connect to relational systems. So who knows how MapReduce works? So MapReduce is really coming out of Google papers, because the way, if you think about the problem a search provider has, you literally have a copy of the internet, maybe multiple copies of the internet on your hard drives. Just try to picture this. To give you an idea about big data, what really, really big data can be is the Hadron Collider in Switzerland, the CERN, that produces a petabyte of data per second. It's cool, isn't it? You have one guy just employed to buy hard drives and installs them. So you need to have it distributed. But if you think now, big data is nothing for me, it's actually not necessarily true. Because as soon as you store data across one disk or two disks, it already requires you to think how you can make sense out of this. And what I'm going to show you too is you can run simulations where you create for a very short time a lot of data and then you kill it. And MapReduce is a way, a framework that allows you to write a map function and a reduce function that can be highly paralleled compute across these nodes. So if you look at the map function, as the input of the map function, you get a key and a value. And what you're going to emit, your output, is a list of key and values. And then the framework does some very interesting stuff in between, and then it calls your reduce function and gives you the one emitted key of the many emitted keys from the map and gives you the list of all values which belong to that key. Smart, huh? And what you're going to do, you emit the key 2 and the value. So if you would like to count words in a document, and that's the hello world of Hadoop, is count words of a large document, or count words of a library, and then give me the top 10 words. The way that would look like in JavaScript is you would have a map function, and you would have a reduce function. And both application, and then we're going to see how that stuff actually looks like. So it's called Event Body, so it allows you to organize event. The first thing is I can log into this application. But I'm not logging in with username and password, but I'm actually logging in with an option of identity providers. Because the only thing I need to know is that you're always the same person who comes back. And I don't care whether you want to authenticate yourself with Facebook or Twitter. I just need to have an ID to recognize it's you again. So I'm going to use Twitter. I'm connecting now to the Twitter service, so their login account. Provide my Twitter credentials. I authorize now my app that it can access certain things. And you're going to see on the very top, I'm now logged in with my Twitter handle. So I can now create new sessions. So this is a new event. Let's call it Azure in Finland. In addition to this, now I can create a new session. And I just call this Intro to Windows Azure. And let's say I add the speaker is going to be Mr. Cloud Biaggi. And we're just going to retrieve the URL, the profile picture from Twitter itself. So there's really no rocket science here. What we have in addition, and I think now it becomes very interesting, we integrated also tile notification. So I have now a... So Jukka, can you rate my Keynote, please? Oh yeah, Jukka just rated my Keynote. Ah, thank you. So the way this works is we also have a Windows Phone version of this that simply just allows you to say, okay, I want to give 5 stars to this particular session. What's happened now is mobile services recognizes what are the devices I'm logged in as Cloud Biaggi and sends me a notification. So if we switch back here, you see now it's not Jukka anymore, but it's me. So it's fairly straightforward. So let's have a look into this. It's actually fairly simple. So I go to Windows Azure, my mobile services. I go on the Event Hub here, Event Body here. So the first thing I would like to show you is identity. I simply just configured the identity providers here. You get them actually, I'm switching fast, so you're not making pictures of my, but you kind of get the point. It's a secret and a couple of keys that you get from your respective identity provider, whether Twitter, Facebook, Microsoft account, and so forth. And then within the application, you then simply just use the proxy that we saw Jukka created yesterday with mobile services, and then I say login asynchronous, and you pick your respective identity provider, whether it's Facebook, Google, Microsoft account, or Twitter. That's all. And if you look what you're going to get back on login asynchronous, you actually get a mobile service user, which gives you the ID of that particular user. This is extremely simple, really simple. So let's have a look into how we handled the push notification. We just store, the required push notification information for the particular application. And you can do this actually with Apple Push and Android, so the Google Cloud Message Push as well. You just retrieve the push settings for your application. And then what Jukka already showed yesterday, we have a couple of tables. Session, rating, event, that's fairly clear. So what is the channel table? In a channel table, I store the push notification channel together with the Twitter ID. So if we look into this, you simply see this is my push notification channel, and it's associated with my Twitter ID, because that's my Twitter ID. It's only one channel, it's this computer. So the only one at the moment receiving push notifications. So what I do now, I'm creating a script every time someone inserts a new rating. So if the mobile app inserts a new rating into this table, I run a script. So mobile services allows you to run Node.js, so server-side Java code. So it's Node.js that you can do here, and you can do a lot of stuff with it. So you can access blob storage, you can call web services, you can call whatever you want. So what I run here is a simple SQL query to retrieve the channel, so I know the correlation between the Twitter ID and the push channel, and then I use this method here from the Windows Notification Service object. And I already showed you the documentation for this in the very beginning. So now let's change this and add a push notification. So a push notification, a toast notification, which shows me a toast message on the top. And this is then called send toast, because I just picked the one which has the same parameters, so I don't need to type. So send toast image and text 03. That's the one I want to shoot. Just double check 02. That's the one I want to shoot. So I just save it. And Jukka, can you just see whether that app works? Yep, you see? Got a push notification as a toast from Jukka. Just added some server-side stuff to it. In addition to this, we can actually do some other interesting things. I have a scheduler. So where you can do some math in the background and then send stuff, or you could create your live tiles every 15 minutes and send it to, take some nice pictures. So what I'm going to do is I create a quick scheduler and just going to send every 15 minutes an average rating. So I know exactly every 15 minutes how I'm doing. So I create a schedule job. So you see, you can define whether you want to run it per month, day, or hour. So let's call this send average rating. Huh? That's it. So now I can just write that script, which literally is just like this. I run a SQL query to get, and then I get the average grouped by the channel. And then you see here, I'm going to send the tile-wide notification message. So it should appear on the start screen. So let me run that stuff. It's fairly straightforward. It's really just Node.js, and then how you can connect to the SQL which runs here on the back end. The reason why you actually see everything is red here is because it needs the method needs to match. Oops. The name, so there is a problem with exactly. So the very top, the function name, and it even will be red too because I have a low. Where is my? Oh, here. I have lowercase and it's uppercase. So as soon as I switch this to lowercase, I'm going to be fine. So you see, there's even kind of intelligence in that whole thing. I save it, and then I run it once, because I don't want to wait 15 minutes. You want to get your lasagna. And you see my average session rating just updated. If one of you started doing that stuff from scratch with push notifications for Android, iOS, Windows Phone, Windows Store apps, you're just going to appreciate how easy it is to do so. Can we switch back to the presentation, please? So that really brings me to the conclusion. And that is very, very simple. The cloud is a game changer. But not because it's the cloud, because it enables you to do stuff you haven't been able to do without it. It changes the access to scale and to reach. And that just opens great opportunities. Our cloud for developers is Windows Azure. It is a first-class platform as a service and infrastructure as a service offering, and is open to, you name it, technology. We work with open source communities to make their project running the best on Windows Azure. So with this, I hope you got a good overview of where we are today with the platform on Windows Azure. Don't forget, actually, to try out Windows Azure, because you have 10 websites for free, you have 10 mobile services for free, which means you can run for 10 of your family members WordPress blogs if you want. Or you can have 10 experimental mobile services, or you even can run one in production. So really go on windowsazure.com, play around, and have fun. With this, I really, really wish you're going to have a good lunch and a nice rest of the conference.